Hello and welcome. Today we're going to take a look at an LC hard problem, Alien Dictionary, number 269. There's a new alien language that uses the English alphabet. However, the order of the letters is unknown to you. You are given a list of strings, words, from the alien's languages dictionary. Now it's claimed that the strings in words are sorted lexicographically by the rules of this new language. If this claim is incorrect and the given arrangement of strings in words cannot correspond to any order of letters, return an empty string. Otherwise, return a string of the unique letters in the new language sorted in lexicographically increasing order by the new language's rules. If there are multiple solutions, you can return any of them. And here we have three examples. So WRT, WRF, ER, ETT, RFTT, and the output is worth. And then we have Z and X, output ZX, and then we have an invalid ordering Z, X, and Z again. The order is invalid, so return an empty string. Okay, so let's take a look at the drawing to see how we can approach this problem. Okay, so we have the first example, and we're going to go through it. So if you've already went through the verifying an alien dictionary problem, then this one is similar, but it's a lot more complex because there are a lot more things to do. But we are going to have to process the words in a similar way to the one in that problem. And we're going to take the first two words, W, R, and T, and W, R, and F, and we're going to check for the first different character. So there's going to be T and F, and then we're going to say here T comes before F. Okay, then we take the next pair of words, WRF and ER. And here we can see that the first character is the one that's different, W and E. And we say the W comes before E. W comes before E. Okay. Then we take the next pair of words. We take ER and ETT. And here the first character is the second character, R and T. So R comes before T. R is before T. Okay, and then we have ETT and RFTT, from which we can say that E comes before R. And as we can see, we get the word worth, right? So that's great. So we have our solution here, but how do we actually process this? You can see that this looks like a directed acyclic graph, like DAG, and we have the nodes represented by the characters in this alphabet. Okay, so we can process this in either depth first search way or a breadth first search way. And for this video, we're going to look at the breadth first search approach. And for that, we're going to use an indegree array or map. And we're going to store the indegree of the vertices. So that means the number of incoming nodes. So for W, we have 0 incoming nodes. For E, we have 1. For R, we have 1. For T, we have 1. And for F, we have 1. And this algorithm is called Kahn's algorithm or topological sort. And we're going to go through it using we have a queue, and we always add the element with indegree 0 in the queue. So if you have an indegree 0, we add it to the queue. So we start with W, And then we check the neighbors of W. The neighbors of W will be E. So we take E. And then we subtract the indegree of E. It's like we remove the edge from W to E. And now we'll have an indegree of 0. So it's like we remove that connection. So now we take E as the, because it has an indegree of 0, we push E to the Q. And we take the neighbors of E, in this case R. And again, we remove the connection. We subtract the indegree. It's going to be 0. And as we do this, of course, we also add our results to our characters to the result. So W and E have been added. And then we take R, and we take the neighbors of R, T, and we remove the indegree of T. And so on. We remove the indegree of F as well. So T has the neighbor F, and F has no neighbors. And once we process F, we have added all of our strings, all of our characters, sorry, to our resulting string, and we have our solution worth. Okay, so how do we do this in code? Well, we need to build a graph, and then we need to use breadth first search to process it in a similar way to that I've shown here. So let's go to the code. Okay, and let's start. So we create a graph, which is an unordered map of a character, and then we're going to store a set of characters because we do not want duplicates. And we create a graph here. And then we have a function to build this graph. And then we need our indegree vector, or you can also use a map, but we know that we have only 26 characters, so we can use a vector for this. And we initialize all the indegrees to 0 by default. And we pass in the graph. And we pass in the words. And we pass in the indegree. Okay, and for each word, we initialize the graph, so we add the character to the graph. And then we process the words. Similar to verifying an alien dictionary. So word of I-1, word of I, and then we're going to compute the mean length or the maximum for J, which is going to be minimum of the first size, second size. And we're going to check if we have a difference that was found between the two letters, the two words. And if first, so for int J, so we go character by character. And we check here if the first of j is different to the second of j. Found the difference, so we mark that as true. We break because we don't want to process any further characters. The first character that we process that is different is enough. Okay, and then we also update our graph. So if out character is going to be right, the outgoing edge first, and it's going to go into second. So graph of out, insert, ready to set in, and then if this succeeds, insert returns a pair, and the second is a boolean. The second value of the pair is a boolean that tells you if the operation has succeeded or not. In degree of in plus plus, here we increment our in degree. So that's how we compute our in degrees, to make sure that we only do it for the unique characters that have been inserted into the set, and we don't do it twice for the same character. And that's how we build our graph. Now, if we have a prefix, or that's an invalid ordering, if we have a prefix like apple and app, for example, the same way as for verifying an alien dictionary, the other problem, which I recommend you go through before this one. If we check here, if first size is greater than second size, so if the first word is greater and we haven't found the difference, then it means we have an invalid prefix like apple and app instead of app and apple. And then we return false. And otherwise we return true. And that's it. We have our graph. We have it built. So if build graph of graph words in degree, we have our graph. So if this fails, we return result, and we initialize it here. Result. And we also need to make sure that our result size is correct in terms of the total number of characters. Otherwise, we have an invalid solution. Okay, and then we need to actually do our topological sort. So first we build the graph, and then we do the topological sort using breadth first search. So we can just return the result with the topological sort function. We're going to have a string stream, and we're going to return the result. And we take in the graph in the in degree. And we initialize our queue. And then while our queue is not empty, we have to do something, but first remember we have to initialize the queue with those nodes that have an in degree of 0, right? Okay, and here in degree of in minus a, because we are using a vector, not a map. Okay. So we push the sources, the ones that have an indegree of 0, and then we process these nodes. We add this to our result, to a string stream. It's just more efficient if you use a string stream than do it directly on the string. Okay, and here we get the neighbors of current. If the neighbor, if indegree of neighbor minus a, if minus indegree of neighbor minus a equals 0, then we push this to the queue. Okay, and otherwise we continue with our breadth first search, and that should, we just need to call this now, topological sort. We need to call this here. Result is topological sort of graph and indegree. Okay, so let's see. Probably some things are wrong here because it's a lot of code. Set of char. And the first 3 results are accepted. And accepted. So time complexity is O of n plus e. And space complexity should be O of n for the unordered map in terms of the characters. That's it. I hope you enjoyed this problem today. Hope it helped you understand how it works, how topological sort works. Please let me know if you have any questions. Like and subscribe if you like the video. And stay tuned for more C++ problems. Thank you and bye.